Okay, good morning class. We're on to our grade 10 mathematics experience. This is Mamu Jarvis, and this morning we'll be looking at an aspect of algebra that talks about quadratics. So, what is a quadratic? A quadratic is a trinomial. A quadratic is a trinomial. What is a trinomial? A trinomial is an algebraic expression having three terms. For example, I could have ax squared plus bx plus c. This is a trinomial because I can count three terms here. 1, 2, and what? 3. We also have been taught something called binomial. A binomial is an expression having what? 2 algebraic terms. Let's take ourselves back a little. Now, remember that generally when we talk about algebra, we're concerned with 2 types of expressions or equations. Or let me rephrase the statement. When we talk about algebra, we're concerned with 2 key ideas. That's a better way to say it. We have what is called equations. And we also have what is called expressions. Every description in algebra or equations, okay, we talked about equations, we talked about expressions. So what then differentiates equations from expressions? This is not a class for that discussion, but just to help you understand what we have to do today. An expression is a one-sided mathematical statement. An equation is a two-sided mathematical statement. What it means is that for every equation you have a left-hand side, you have a right-hand side, connected by what? An equality sign. So, because our focus is not on any other aspect of algebra but on quadratics, it's important for us to have what I may call an agreed definition for what a quadratic is. A quadratic is either an expression or an equation where the degree of the unknown is 2. Let's have a general form. We have what is called a general form for the quadratic, giving us ax squared plus bx plus c. Ax squared plus bx plus c. A, b, and c are treated as numbers, or better still, okay, this is a constant. We're well aware of that. This is a coefficient. This is another coefficient. So in practice, A, B, and C are numbers. So all of these in practice are what? Numbers. They are what? Numbers. The emphasis in a quadratic is this one here. So we said that the degree of the unknown is what? 2. It means that when we deal with a quadratic, we expect to get, if we're dealing with an expression, we expect to get what? 2 factors. If we're dealing with an equation, we're expecting to get what? 2 roots. Take note of these terms. Take note of these terms. Roots and factors are technically not the same. What you obtain from your expression or expressions are what? Factors. The factors enable you to get what? Roots. The roots are specific values of the unknown. When we solve more, you begin to appreciate what's happening in quadratics. But be rest assured that When we deal with expressions, what we are concerned with is factors. When we deal with equations, what we are concerned with will be what? Roots. You can't be talking of roots except you have been able to obtain the factors. As a way of added information, there are 4 types or 4 methods of solving quadratic equations. There are what? 4 methods of solving quadratic equations. So let's see. Methods of solving quadratic equations. Now remember that I've not gotten to quadratic equations here, but I think it's important you hear this, and this prepares your mind for what is to come. Number 1, we have what is called factorization. This is the most important method in solving quadratics or quadratic equations. Factorization. In fact, a whole lot of the work we're going to be doing under algebraic or quadratic expressions will be factorization. Number 2, we have what is called completing the squares. Completing the squares. And the last method we have is the method we call, or rather the third method we have is what is called the formula method. And we have the final one, which is called the graphical method. So 4 methods you can use to solve quadratic equations. Please and please, I always tell students, I noticed teaching over the years that students seem to run away from understanding this concept. If you don't understand this concept very well, you will find it difficult when it comes to quadratic equations. Especially if you have an examiner that constrains you to a particular method. Let me, by way of added information, tell you that formula method is no different from completing the squares. In fact, the formula you call the quadratic formula is obtained by completing squares. We're going to treat all of that when we come into equations. But for now, we will settle our hearts to see how we can obtain factors when given quadratic expressions. Okay, our textbook of reference is the New General Mathematics for SS1, and we will be looking at page 120, and we're going to consider exercise 10A. I'm going to go with the method of exploring, so you're going to be seeing things for yourself. If you look at the first exercise, usually of any new topic, it's a revision. At least to say that you've been taught that before. But it's always nice to assume that you may have forgotten, or perhaps when you were taught, you didn't have a strong grasp of it. Or it's likely too that you have never been taught at all. So we'll try to keep it simple and see how that works out with us. To handle this aspect of quadratics, you need your knowledge of arithmetic. Your knowledge of arithmetic is very, very, very important. So we're going to do something very quickly on the board, and I want you to take note of this, because this is going to form the basis of a lot of things we're going to be doing. Now look at this. If I have odd plus odd, what would I get? An odd number plus an odd number. I have an even number plus an odd number. What do I get? Well, let's say plus or minus. Plus or minus, because the answers will be the same. If I have an even, an odd, plus an even, plus or minus an even, what do I get? And if I have even, plus or minus even, what do I get? The conclusions from this will serve a very great purpose to what we want to do here. If you add up or subtract 2 odd numbers, you will get what? Odd. Sorry, you get what? Even. Let's take an example. 3 plus or minus 1 will give you what? Will either give you 4 or will give you 2. Please take note of this. This is very, very important. It's the reason why sometimes you waste a lot of time when you're solving, when you're trying to handle quadratic expressions. Now, if you have even and odd in any order, you're going to get odd. We'll take another example. If I have 2 plus or minus 1, what I'll likely get will be 3, or I'll get what? 1. Take note of the conclusions. We call it the example approach. We write the conclusion and we use an example to validate what we are talking about. Now, odd plus or minus even, we still give you odd. The order of arrangement does not affect the outcome. Order of arranging in terms of odd and even, numbers are either odd or even, whole numbers for that. So if you have 1 plus or minus 3 plus or minus 2, I'm going to have 3 or what? Minus 1. Now we come to even. If both numbers are even, I'm going to get even. So what I'm going to have will be what? Let's say 2 plus or minus 0, because 0 is an even number. What I'm going to get will be what? 2 or what? 0. So I need you to take a very close look at this, because this is what you will need in handling your problems. Now we've done that for addition or subtraction. What now happens in multiplication? Please follow me closely. You get to see the reason why I'm going through this process. Because when I start solving, you'll be amazed at the speed with which I get my answers. It's possible, very possible. The day I discovered this technique, I was like, wow, so this is really in existence. You must learn to discover things. So let's look at this. I have odd times even. What do I get? I have odd times odd. What do I get? I have even times even. And what do I get? Then I can also take even times odd. What do I get? Anytime you multiply an even with any number, whether odd or even, you must get an even. Even is dominant here. So my answer in any arrangement where I have even multiplying will give me even. We can take examples for that. 2 times 1. Or let's keep it that order. 1 times what? 2. I'm going to get 2. I take this one. 2 times 2. I'm going to get what? 4. I take this. 2 times 1. I'm going to get 2. So you see that the outcomes are what? Even numbers. But if I multiply 2 odd numbers, I must get what? Odd. I see that? And that will give you what? Let's say 3 times 1, and that will be what? 3. So let's have this down. And then, based on this, I'll go into quadratics. The other ideas I will drop as we solve. But for now, these are the basic you need to remember in handling quadratics. Some other methods exist, but I think a lot of them involve you cramming and trying to. This is very straightforward. Once you see it, you apply it, you run. Alright. So straight away we go into exercise 10A. And we are told to factorize. We are told to what? Factorize. Factorize the following. Exercise 10A. Let's look at number 1. I'm going to pick a few of the questions and use them to explain what we expect you to see. In question 1, we are told x squared plus 9x plus 14 to factorize this one out. What I discovered over my years of teaching is this: students will just do the thing, but they don't understand what they are doing. I had that challenge when I was even growing up in secondary school. I could do it, but I couldn't really explain why. But thank God for research, I've been able to understand why these answers are like that, and that's what I'm going to be trying to do in my videos. I'm trying to help you understand the logic behind these decisions. Now let's look at, to handle this, the first objective in factorization is to have your factors as what? An even number. Let's count the factors, your terms you have here rather. 1, 2, 3. How many terms are you seeing here? 3. You cannot factorize when you have 3 terms. you can only factorize terms usually in multiples of 2. So it's either you have 2, you have 4, you have 6, you have 8, you have 10. If the terms are odd, you will not be able to do what? Factorize them. So your first goal is to ensure that your terms are even. So maybe you've never heard that before. Hear this now. The first thing you do before you factorize, so make sure that your terms are even. If they are not even, you can't factorize. That's number one. So the next thing you need to take note of is this. I'm going to be giving identity to each of the position. Now, this one gives you what is called the sum of factors, SF. This position, now take note, this is first, this is mid-term, and this is last term. Come again. This we call, maybe we should name the terms first. This is first term. This is what is called mid-term. And this is what is called your last term. First, mid, and last term. This middle term, now please take note of something. This middle term is described like this. So if this were to be negative, the value of the middle term will be what? Negative. For those of us who are already acquainted with these things, it will not be strange to you. Now, this one is what is called your SF. We call it the position of the sum of factors. And when I multiply this with this, what I obtain is what is called the product of factors. So, in building this method, what I'm going to do is to demand a little from you to understand why you are making those decisions. A lot of times, people they just solve. You call a student, how did you get this? They can't really explain to you why that is happening. So this class seeks to help you to understand why those decisions were made and why you shouldn't do otherwise. Now look at this. According to the arrangement I have here, my sum of factors will be what? 9x. Now, take note of something. Okay, let's keep that for later. Maybe later I will show you something else. By the time you understand this technique, there are certain things you can actually look away from. Now, your product of factors will be what? This x squared times what? 14 here. And that will give you 14x squared. I usually tell my students, don't bother about x or what? X squared. Because if I multiply two numbers, two terms, I would obviously get x squared. If I add up terms, I will get it in x. So I tell my students usually to just write 9 here and just write what? 14 here. You know in your mind that they are in what? Terms of what? X. Once you have done this, the critical factor now is this, to find your factors. So watch carefully. What is the sum here? Is it positive? I need you to respond. Respond. What is the sum here? Positive, is that not? What is the product? Positive, is that not? Now remember, I don't know whether you have been taught that. If I have positive times positive, what do I get? Positive. If I have positive times negative, what do I get? Beautiful. If I have negative times positive, what do I get? Beautiful. And if I have negative times negative, what do I get? Please take note of this. That's another important idea you need to make your decision here. This is positive. This is positive. Your factors must be both positive. Must be both positive. Now, the next thing you need to look at now is to get the factors proper, you need to look at your product. Look at this number. What's this one here? 14. What do you have here? What type of number is 9? Is it odd or even? What type of number is even? What type of number here is even? Is that not? Now look at this. If I have my sum as odd and I have my product for factors as even, it means that the numbers I need to multiply to get my answer, one must be odd and the other must be even. Because when we're treating addition and subtraction of odd and even numbers, it was only under this possibility we had the answer as what? Odd. So the factor one will be odd and the other will be what? Even. Once you know that, look at 14. How do you break 14? 7 and what? 2. Good. So this will be 7 and this will be what? 2. So you bring this back in and this will be what? X squared plus 9 plus 2x plus 7x plus what? 14. And with that, we will proceed to now have x squared, I'll just rewrite that, plus 2x plus 7x plus 14. Now at this point, I will look at, remember I said that you cannot factorize terms if they are odd. You need to factorize terms in the neighborhood of them being even. Okay, so this will now be what? X into what? We don't deal with terms in terms of them being odd. They must be even. Why? It's easier to share 4 things than to share what? 3 things. If you share 3 things among 2 persons, they will fight, they will quarrel, they will grumble, they will complain. But if it is 4, you know that you will get 2. The other person will get 2. And everybody walks away happy. So that's what we're going to try to do now. So I will look at these 2. And I will look at these 2. From these 2, I can get x as a common factor here. And I'll be left with x plus 2. I look at these 2, I'll get what? Plus 7. And I'll be left with x plus 2. And that will be equal to what? X plus 2 is common to both. And that will be what? X plus 7. Now, I have seen lots of books where you look at it and just get your answer and you walk away with factors. There is a danger in that technique. Because if the coefficient of this is not 1, that your method will not work. It's one of the reasons why when I teach students this topic, I take pains to take you through. This is really demanding. Yes, it's better. I take you step by step so that you understand what you're doing. Your brain works better when it understands what it is doing. A number of things some of us are struggling to write out are things that our brain naturally can deliver for us. So this is the first question we have done. We'll go over it again. Step, you get your sum of factor, product of factors. Then you make your decision for your factors. These factors would expand this. Remember we said that this position is the sum of factors. Position. Is that not? If I add this to what do I get? It's not a 9. It's not a 9. So that's the importance of this position. It gives you the idea of the sum of factors. So that said, you spread it out like into 4 terms and then you factor out what? X. You get this part, factor out 7, you get this part. And after that, you factor out x plus 2. You discover that watch. If I look at this 2 and look at this 2, this is what is common here. This is what is common here. I factor that one out. When I factor x plus 2 here, I'll be left with x. When I factor x plus 2 here, I'll be left with what? 7. And then we are done with that problem. In question number 2, what you observe is that the sum of factors is negative 12. Why? It's negative. So I will just put negative 12, which is what I normally do, because writing y or y squared really does not make any difference. Now, we come to the product of factors. We'll be multiplying this first term with the last term. And that will give me what? 35y squared, which I'll just write as 35. So what will be the factors? You consider the product, it is what? Positive. You look at the sum, it is what? Negative. Now there are 2 possibilities here. If I multiply 2 positive numbers, I get positive. If I multiply 2 negative numbers, I get what? Positive. So, there are 2 possibilities for me to get what? Plus, when I multiply. But look at the sum. What do I have here? Negative. That tells me that the factors I'm looking for must both be what? negative. So I'll come here, I'll put my negative, I'll put my negative. The next thing I will check, I look at this, I have what? 35. It is odd. I come here, I'm seeing 12. It is what? Even. Now, remember that if I multiply two numbers and I'm getting odd, and I add them and I'm getting even, it will only mean one thing. The two numbers I'm looking for must both be what? Odd. This technique will help you get your factors faster. I will look at 35. I'm seeing 5 already, so it is 5 times something. 5 times what? 7. It looks very simple here. When we deal with deeper questions, discover that it may not be easy for you to just look at the number and tell. But if you use this technique and know how to use it well, you'll be able to get your answers faster. So I know now that both factors I'm looking for must both be what? Odd. So I'll come here, 7, and I'll come here, 5. I'll transfer this to where I have what? 12y. This becomes y squared minus 7y minus 5y plus 35. Okay? So what does this give you? This will give you, I will break the term. Now when you're breaking, now you will break such that, please watch this. This negative is attached to 5, so it will be attached to this part of the factors. So you have what? 5 squared minus 7y. Alright, so let's finish this one now. So look at this. What is common to these two? It is y. Watch. Usually for the first and second term, y is usually, or x is usually common. So this will be y into y minus what? 7. Now, on this part, I'll take it step by step. 5 is common to both. Is that not? So I'll say what? Plus 5 into what? Minus y plus what? 7. Now if you look at this carefully, I'm seeing negative y here. I'm seeing y here. So what do? Your task is to try to make this one to look like, this. So this becomes what? Y into y minus 7. And we factor negative out. And this will turn this one to become what? Y minus 7. At the end of the day, you have what? Y minus 7. Always write this one first. Some of us will just say y minus 5 into, no. While it doesn't have any implication in the exam, it has an implication in your understanding. Always factor, this is what you are factoring out. What is left is what you write next. And that will be what? Y minus 5. Alright, so those are the ones you'll be able to handle right now. I will trust that sooner or later we'll go deeper into some other questions, and we'll trust that you would end up doing better in this topic. Okay?